Okay, so the last thing we're going to do in this lesson is just work some more example problems of calculating areas. The first one says a rectangular plot of land is to be seeded with grass. If the plot is 22 meters by 28 meters and a 1 kilogram bag of seed is needed for 85 square meters of land, how many bags of seed are needed? So the first thing I would do if I was teaching this in a class to students is I would draw a rectangle. And I would label the dimensions. This is 22 meters by 28 meters. And I want to seed this with grass. And so I'm going to cover the interior with grass seed, which is what makes it an area calculation. Now, area for a rectangle we know is length times width. The first thing we need to make sure of is that both of the length and the width are in the same units. And they are. They're both in meters. And so that's good. We can go ahead and calculate the area by doing 28 times 22. And when we do that, we get an area of 616 meters squared because we did meters times meters, which is why this is in meters squared. It takes 616 square meters to cover this plot of land. Now, one bag covers 85 square meters. And so in order to see how many bags we need, we're going to take the total area 616 and divide it by 85 because each bag will cover 85 square feet. Now, if you do this calculation, and you can use a calculator, but if you do this calculation, you're not going to get an exact number of bags. And so you can go ahead and divide this out by long division if you want, or you can use a calculator. On this particular problem, I would let you use a calculator. So when you do that division, you get approximately 7 and 2500ths. And so if we were going to go buy bags of seed, 7 would not be enough, which would mean to cover this in seed, I would have to purchase 8 bags. Okay, on the next one, we're going to find the area of a triangle. So area of a triangle, the formula is the base of the triangle times the height of the triangle divided by 2. And I have both the base and the height. But one thing that's really a big deal for this particular problem is one of my measurements is in centimeters and the other one is in meters. And so we do have to make a conversion. Now I'm going to choose to convert this to centimeters. That way I'm not going to have any decimals when I do this. I'll still have all whole numbers. So 6 meters, if you think about the conversion, and we can come back up here and even look at the conversion chart. So if I'm right here at 6 meters and I want to go over here to centimeters, that's 1, 2 to the right. And this is a length. Don't confuse this with us converting an area. We don't double the movement here because we're not converting the area. We're converting a length. And so it's just 2 units to the right. We don't do times 2 because this is just meters. This is not meters squared like we did right here. So if I go 2 to the right, what this makes is it's going to make 600 centimeters. And now both of these lengths are in the same units. So I can do the base 600 times the height 3 divided by 2. And a lot of students will miss this because they won't recognize that these are not in the same units. And so make sure you pay attention to that on your assignments. When we go ahead and do this, this will now be 1800 divided by 2, giving me an answer of 900, and I went to centimeters, so it's centimeters squared. All area is measured in square units. The last example is a fun one. We have a circular flower bed that is 10 yards in diameter, and it has a circular sidewalk around it that's 2 yards wide. Find the area of the sidewalk in square yards. Leave your answer in terms of pi. So what we have is we have this flower bed that is 10 yards across it, and then it's surrounded by, and always ignore my drawings, but it's surrounded by a sidewalk that is 2 yards, and that looks kind of like it's 12, but it's not, 2 yards all the way around it. And what I want is I just want the area of the sidewalk. So I'm going to kind of do squiggles through here. All I want is the area of this sidewalk. So what you would do to do that is you're going to do the area of the big circle and then remove the area of the small circle. And when you do that, when you remove this small circle from the big circle, what you're left with is the area of that sidewalk. So what we need for area is we need the radius. So the big circle, if you look at it all the way across, for the big circle, it would be a diameter of 14 because it would be this 10 plus this 2 here plus this 2 here. So the big circle has a diameter of 14, making it have a radius of 7. The small circle has a diameter of 10, making it have a radius of 5. Now, if you'll recall, area for a circle is pi r squared. So that's going to be pi times 7 squared for the big circle, minus pi times 5 squared for the small circle. This would give me 49 pi minus 25 pi for the small circle. And because these are both in terms of pi, they're basically considered like terms, we can subtract them. When we do subtract, that's going to give me 24 pi. And recall, I'm in yards, so it's yards squared for the area. The area would be yards squared. So that's kind of a fun problem to finish off area practice.